Okay. So rows are labeled by here the states and the columns are labeled by the type symbol. This I includes input symbol as well as the type symbols. Okay. So this indicates what the current state is alpha and the current input symbol is 0. Then it indicate what? The 0 remains as it is not erased. State also remains the same and it moves to the right direction by one cell. Here this indicate what? 1 is replaced by the 0. State is changed from alpha to beta and it moves to the right direction. Okay. Change that is if input is not changed or if the state is not changed, if it remains as it is, no need to write it. We can write it in the simplified functional matrix that here 0 alpha it is changed, then you have to mention it. Okay, so this is what the simplified functional matrix. Okay, and then we have seen the mathematical model of this. Okay, so in the mathematical model, what we have seen, there are the 7 symbols. Okay, where Q is a what? It is a finite set of states. Q is a finite set of, this is a finite set of input symbol and this is a type alphabet. Okay, here finite set of input symbol, it is a subset of the type alphabet. Okay, so this indicate what? It is a finite set of allowable type symbols including blank character. Okay, here Q0 is a what? Initial or the start state, which is from the which belongs to the Q. This indicate what? Which is an element of the Q. Okay, then F is a what? F is a set of final states or hard state. Okay, now in this case I told what? If once you reach to the hard state, there is no outgoing edge from the hard state. Okay, B here is a blank character and delta here is the what? Functional matrix. And how it is indicated, that we have seen, given the state, this is a type symbol. It gives what it indicates, the next state. Here this is again, this symbol will be from that type symbol and the direction. Okay, so now here we'll take example. I'll take one example which is already solved, and for that example we'll consider the simulation of the for the given string as well as how to draw the transition graph for the Turing machine. Okay, so let us consider a simplified functional matrix for a Turing machine, and here the values are given. Let I is equal to 0, 1, blank. Okay, so what this indicate? These symbols will appear on the tab, and the states given here are let alpha, beta, gamma, where this is let a hard state. There will be one hard state. Instead of final state, here it is hard state we are considering, and direction here can be what? Left, right, or the no. This will remain same in all cases. Okay, direction. And now let the simplified functional matrix is already given, and let the matrix here is I, S. Note down this, and then we'll consider the example for the simulation. So input symbols are 0, 1, blank. So this moves to the right. Here 0, beta, right. This is the right direction. This is a simple Turing machine given. Okay, so here you can see, once you reach to this state, this is your hard state from which there are no outgoing edges. Okay, so what this indicate here, here you can consider what is it doing whenever you're always starting. Here again there will be some initial state. So let the initial state here is alpha. So if the input is 0, it keep on moving to the right, and whenever it gets the 1, what is it doing? 1 is replaced by 0. The state is changed to the beta and it moves to the right. Okay, and then in the beta, now you are in the beta state. After this, in the beta state, if you get the blank, what is it doing? It is changing state to this gamma, and no movement. Okay, so gamma is the hard state. So once it is reached, it is your final state. Okay, so this Turing machine is what? So this Turing machine, it is accepting what kind of strings? All string of zeros ending with 1. Let us consider only this type of strings it is considering, because after that it is going to the hard state. Okay, so you can see here, this alpha, this we have assumed. Okay, what is our current state? Alpha. This is our first symbol. So after reading 0, what is it doing? Alpha state 0. On 0 reading, what it is doing? It is moving to the right. Okay, state remains same because state is not changed here. Now still you are in the alpha state. Now in the alpha, if you get the 0, what you have to do? Move to the right. Okay, state remains same. Then after getting 0, again it moves to the right with the state as a what? Alpha. On 0, it moves to the right with state alpha. Now in the alpha state, if you get the 1, what is it doing? This 1, now when you move to the right, what is the next state? Beta. And in beta, if you get the blank now, what is it? It is your state is changed. So this is your, okay, so this is a very simple case of the Turing machine. Okay, it is considering the string of what? All zeros ending with 1. Okay, so if you consider here, it is a blank, it just move to the right, and we are not reaching to the hard state. We are reaching to the hard state only from this, that is in the beta state. If you get the blank, then only you are reaching to the state. Okay, so this you can write it step by step. Okay, so let us write it step by step simulation. So here, let us write the same string, blank, 4 zeros, 1 blank. Okay, so this is our initial configuration, and our state here is a what? Alpha. Okay, so next what you have to do? Next, what is to be done? You may start here with the this 0, or you may start with the blank. That depends on what you assume. Here we are assuming we are starting with the 0. Okay, so alpha 0. So what is the transition? What is alpha 0? It is given here, no? Alpha 0. What I have to do here? Move alpha to the next symbol, as the action is right, move to the right. And here you can write what is that transition? What is the transition given? And what is given? Right. So this is how you can write at that step what we did here. Alpha on 0, we move to the right. Okay, the same way you can continue the simulation. Here 0 0, and now in this case 0 alpha is again what? You move to the right, 0 1. And what transition we perform here? Delta of alpha 0 to the right. So this we perform. Okay, so like this way you continue. This is what the simulation. So 0 0. Here again what we perform here? Alpha on 0, so we have to move it to the right. Alpha. So what is the transition that we perform? We have read now 3 zeros. So alpha 0 is what? Right. Okay. So next here again, in the next step, what is our action? Alpha and 0 is what? Will move to the right. Okay. So 4 zeros we have read now. So alpha will point to the 1 now. And this is what your transition, alpha 0 is equal to right. Okay. And now alpha 1, what is the transition? What is the transition? Alpha and 1. We have to write this, no? 0 beta are So what is it doing? That last one is replaced by 0. The state is changed to the beta and it moves to the right. So transition that we perform here is what? Delta of alpha 1 is equal to what? 0 beta r. Okay. And then finally here in beta, if you get the blank, what is it? Change the state to the we are not writing anything, no, just the state is changed and the direction is no movement. Okay, and here your action is what? Delta of beta comma blank is equal to gamma n. Okay, and then finally you reach to the hard state. Is that clear? How to write the transition or the simulation? This actions only I have written step by step. Here I have written like this way, and here we have performed it step by step. Okay, is it clear? We have to design this. Okay, functional matrix, simplified functional matrix. Okay, so is it clear? Yes, is the simulation clear? So we'll go for the transition graph. Yes. Simulation. I'm not getting any answer. Is the problem clear or not? Yes, anyone? Prachi, number 7. What about remaining students? Okay. And one thing I want to tell, Moharka madam has given the message that today's, I think, CS test will be postponed. So she will inform on which day she is going to take it. Okay. Okay. So for the same example, let us consider the transition graph. Okay. So we have seen transition graph is a what? A graph in which the vertices will be labeled by the states and the edges will be what? The transition from one state to the another. Label each edge. Each edge will be labeled by this only, no? Only thing is what, as we are already showing the transition, like here this transition will be from what? Alpha to beta. Okay. So the edge that will label here is what? Alpha to beta, and the label of that edge will be what? पहले आपका input symbol क्या था? 1. So each edge, okay, I'll show you here. In the transition graph, your vertices are the states. Okay. So let us draw these 3 are the vertices. Here we know initial state or the start state. You have to show using incoming arrow. Halt state here will write, no need to draw here 2 circles, but you write that it is a halt state. Okay. Now we have to add the edges. Okay. So you can see here the edges. So this edge is what? On input symbol 0. But here, what is my next state? State is not changed. So it is remaining in the same state. Okay. But the direction is changed to the what? Right direction. 0 is not changed. So the edge that we will draw here is what? Alpha to alpha. What is our input symbol? 0. So that will form here. We will consider here after this arrow. Okay, so before this arrow, this indicate the input symbol. Okay, so on reading input symbol 0 from alpha state, the transition is what here? The next state is also alpha, and 0 remains 0. It is not changed. So no need to write that 0. We'll write only here what? After this arrow, we'll write R only. Okay. So what this edge indicate? You are in alpha state. After reading 0, you remain in the same state, and 0 is also not change. You are just moving to the right direction. Okay, so similar way, can you add the edges? Can you tell me how you'll draw the edge? So here the state is changed now. So this edge will be from alpha to beta. Okay, and on reading input symbol, so before this, so each edge is labeled like this way. Before the arrow, this is the input symbol. So what will be the here right side of this arrow? What will be the right side of the arrow? No, input symbol is also changed. No, if the input, what I told, state, you will not show this state. No, what is this indicating? यहाँ पे सिर्फ right था, so we have written R. On already you have shown no transition from alpha to beta. So the right, yeah, that is correct. So what you have to write? What you have to write? 0 R. That is correct. Okay. So this is how you'll write that. Is the notation clear? What we did? Alpha, you are in state alpha. On reading 1, 1 is replaced by 0. State is changed to the beta, and you are moving to the right. Okay. So these two edges we completed. Now, what this indicate? On reading blank. So this will be the same edge as that of here alpha on 0. So alpha on beta, it just moves to the right. State is not changed. So this edge is from alpha to alpha. But now the input symbol is what? Blank. And it just moved to the right. Okay. So 3 edges we completed for this 3. Okay. And now here from beta on 0, there is no edge because this is a blank entry. Beta on 1, there is no edge. Beta on blank. Can you tell me how to draw this edge? Beta on blank. The state is changed to the here gamma. Okay, so your edge will be, I will draw the edge. The edge will be from beta to gamma, labeled by this edge from beta to state is changed to the this. Input symbol is what? Blank. And what is the right side of this arrow? What is the right side of the arrow? It is given here, no? Yeah, it is N. Okay. So this is the way to draw the transition graph. We'll again take for another example. For each example, actually, you have to draw this transition graph also. So whenever you are solving the example, first thing you have to write the simplified functional matrix. You can show the simulation for some simple example, and then you can draw the state transition graph. Okay, then only your example is complete. Okay, so now we'll actually solve the example. Initially, I'll consider one simple example that we have already solved for the finite automata. So our example here is now. Our example is, write the example, design a Turing machine. Design a Turing machine. Design a Turing machine to find 2's complement of a given number. Design a Turing machine design a Turing machine to find 2's complement of a given binary number. 2's complement of a given binary number. So in case of finite automata, we have seen the logic. The same logic here will apply. So we know how to find the 2's complement. Okay. So what was the logic that we applied? So let us consider few numbers. If I take the number, let 1 0 1 0 0. So how to find the 2's complement? What we have to do first? To find 2's complement of a given binary number. What is done first? Yeah, we'll first take the 1's complement, that is we'll replace 0 by 1, 1 by 0. So our first step is what? Take the 1's complement. Okay, so we'll replace each 1 by 0, 0 by 1. So like this way. Next step is what? Next step is what? After taking 1's complement, add 1. Yeah. Okay, so if I add 1, so what you are getting? 1 plus 1, 0. This is here carry. So 1 plus 1, 0. 1, 1, 0. Okay. So our given number is now here is what? 1 0 1 0 0. This is our input. And what is the 2's complement? What output we are expecting here? 0 1 1 0 0. So we have seen the logic. Anyone remember in finite automata what we did here? What is the logic then? If this is the input given, you want this as an output. So for this, we have designed their Moore machine and Millet machine, because in that case, we cannot write it to the tape. But in this case, we can replace the input symbols by some other symbols. So what is the logic? Anyone remember? What is the logic of this? If this is the input, you should get this output. Is anyone remembering? We have seen this example. Yes, will I explain? Yes, Divya, can you tell what logic you have to apply here so that for this input you are getting this 2's complement as output?
Ma'am, if like it's first one, for first one, keep it 1, and for next all digits, change it to, if it is 0, change it to 1, and if it's 1, change it to 0.
Yeah, that is correct. Okay. So what we can here, you know that if this is your okay, if this is your input, we'll move to the rightmost here symbol. That is rightmost here is what? 0. Then we'll keep on moving to the left like here till we reach what? The first one. Okay, all zeros will keep as it is till you reach to the first one in this direction. That one will keep as it is, and after that for each 0 it is replaced by 1, 1 is replaced by 0. Okay, so if my input is so in this case 1 0 1 0 0, if I am considering this as a tape, so if this is my initial state, okay, so let us start with the q0. Okay, now in this case we don't want to start from this first symbol, but we want to start from the what? Last symbol. Okay, so what we'll do here, we'll keep on moving to the right till we reach the end of the input. Okay, so for that here you have to keep what? So we'll remain in the same state, but we'll keep on moving to the just right without changing any of this symbol, and then we'll reach to the blank. Blank indicate what? The end of the input. Okay, so after this, so q0 state is what? It is just moving to the right. Okay, now what you have to do? Now you have to move to the left till you reach the left end. So now from this you have to keep on moving to the left till you reach the left end. But during when you are moving, what you have to check, whenever you are getting 0, you are keeping as it is till you read the first one. Okay, so you need to define another state. In that state, what we'll do, let my q1 state is what it is doing, it is keeping 0 as it is, 0 as it is till it reach the first one. So we define another state q1 till we reach to the first one in the left direction. Okay, now q1, what q1 has is doing, it is keeping 0 as it is till it reach the first one. That first one we have to keep as it is. Now beyond this, that is after this one, till you reach the left end of the string, input string, we have to interchange it. That is 0 you have to replace by 1, 1 you have to replace by 0. So we need to define another state, and that will perform that thing. That is, it will replace 0 by 1, 1 by 0. So after this 1, what we'll do, we'll change state to the here q2. Now what this q2 should do, what I told, now in the q2 state, we'll replace 0 by 1, we'll move to the left 1 by 0 till you reach the left end. And now like this way, when you reach q2 to the blank here, that is our what, end of the string, and now you can go to the halt state. So after, when you reach blank in the q2 state, we'll reach to the, that is, we'll change state to the q3, and that will be our halt state. Okay, so what is this is what our logic. Okay, so we'll take one more example. Let, if I take here 1 0, suppose 1 1 1. Okay, so what is our logic here? We know what is the 2's complement. Let us consider 0 1 3 zeros plus 1. Now in this case, what happens? In this case, my input is 1 0 triple 1, output is 0 1 0 0 1. So here the rightmost symbol is 1 only. So it is keeping 1 as it is. Remaining, you can see 1 replaced by 0, 0 replaced by 1. Okay. So what is our logic? What I told you? Okay, Q0. This is our first symbol. So keep on moving to the right till you reach to the blank symbol. Okay. Understand this, because from this we have to design our functional matrix. What I told, starting from the, so this is our initial state. We have to reach to the last symbol of the input string. So we keep on moving to the right. So in the Q0, if you get 0 or 1, you keep just moving to the right till you reach the blank. Now in the Q0, if you get the blank, what I told, now you have to move to the left side, no? So we'll change state to the Q1, because Q0 is different, no? Q0 is performing. Yes? Divya, mute yourself. Okay, so Q1 here. So state is changed to the Q1. Whenever you read Q in the Q0 state, whenever you read the blank, change the state to another state. I'm giving just name as a Q1 and move to the left. Now in the Q1, you are going to read here this 1. So what I told in the Q1, if you get the 0, like here I told, if you get the 0, you keep just moving to the left without changing the state, without changing the input symbol. Okay. So Q1 में जब तक 0 आ रहा है, keep on moving to the left. And in the Q1, when you get the first one, okay, first one, you have to keep that one as it is. Like here, keep that one as it is. Okay. And now after that one, what I told, you have to replace 0 by 1, 1 by 0. So you need to change the state. Q1 is performing different functions, so that's why we have to change, create a new state. Now in this Q2 state, what I told, after this one, we have to replace 0 by 1. So what this Q2 will do, it will replace this 0 by 1. Okay, it will replace 0 by 1 and it will move to the left. Same will repeat, replace 0 by 1, move to the left. And in the Q2, now here this 1 is replaced by 0. This Q2 will get 0, so replace it by 1, and now you reach to the here blank state. And now in the blank state, what I told, when you reach the blank state, you change the state to the Q3 and you can consider this as a halt state, and don't change any direction. So your direction here will be N. So final your state is what? Your here halt state is Q3, and you can see your input is changed now. It is what? 1011 10111 blank. Okay, so from this now we have to write a functional matrix. So how many states we have decided now? You can see. So you have to decide what is your S now, what is your I, and what is your direction. Direction is not going to change. So can you tell me what is our I? Which symbols we have written on the tape for this example? What is our I? So what is our I for this example? Tape symbols. Which symbols we have written on the tape? That you have to decide, because you have to write this the functional matrix as a columns. Okay, 0, 1, and blank. How many states we have decided? What are the states? What is your initial state? What is your halt state? And total states that we have decided? Yeah. There are 4 states, that is correct. Q0, Q1, Q2, and Q3. Yeah, correct. Where what we have decided, Q0 is our initial state. Q0, Q1, Q2, Q3. And here you have to write that Q3 is your halt state. This is what you have to write. Okay. So this work you have to do first, then only you can decide all these things. Logic you have to decide so that you will get the correct output for the given input. And direction, it is not going to change. Direction is here, left, right, and the no movement. Okay. So once this is decided, this logic only, let us write the simplified functional matrix. Simplified functional matrix for this example. So I need this one. We need this logic, what we have used. So right here, simplified functional matrix, I, S. So I here is what? 0, 1, and the blank. States Q0, Q1, Q2, Q3. As Q3 is a hard state, there will not be any entries for the Q3 row. For Q3, there are no entries. Yeah. Okay, now I have already told the logic. What we have assumed here, again I'm writing, this example only, let us write. Input is blank, let 1010. This is our input. And what is the out? 0, 1, 0, 0. Okay, this is our Q0. So what is the action? Because in this example, we are going to start from the rightmost symbol, Q0 on 1. What is my action? I explain here. Q0 on 1. What is my action? What I have to write here? Q0 on 1. Yes, Kunal, that is correct. What I have told, यहाँ पे देखो ना आप लोग, so please understand it. What I have written here, on reading Q0, we just keep on moving, 0 or 1. We just keep on moving right, okay, till we reach the blank. Okay, so if I get the in the Q0 state as a 1 without changing the state as well as input symbol, we'll just move to the right. Okay, so I'll write here simultaneously. Q0 on 1. What we did, we just moved to the right. Okay, now Q0 on 0. Q0 on 0. Yes. Q0 on 0, move to the right. Okay, so we'll move to the right. So like this way, what this indicate in Q0, whatever you get 0, you move to the right. If you get 1, you move to the right. Okay, so we'll keep on moving to the right here. Okay, now whenever you get the blank, what is to be done? Now you reach the right end of the string. Here, what is your action? What will be your action? Q0 on blank. Q0 on blank. No, that is your correct, because blank, we don't want to move further. No, this is unended. See, no, if you write no direction, Piyush, what we have to do? Now we have to move to the left, no? So that now we have to scan in from in this direction, so that, okay, so no direction to nahi aayega, but what we'll do, we'll change state, that is correct Q1, but we'll move to the left. Okay, see what will happen here, blank 1 0 1 0 0 blank, Q0 on blank. What we did, we changed it to the Q1 and moved to the left. Now this indicate this is what, because we have to move to the left now. Is it clear now? Q0 on blank, change state to the Q1 and move to the left. Yes. Now what I told, what we have defined function for the Q1. Q1, what it will do? It will read it. If it gets 0, it will move in this direction for searching the first one. Okay. So in the Q1, if you get 0, what is the output we want? 0 ke liye as it is 0, no? 0 ke liye as it is 0 till you reach the first one. That first one also you have to keep as it is. Okay. So this function we want to be performed by the Q2 state. Okay. Without changing the state, so sorry, Q1. Q1 on 0. What is my action then? We don't want to change the, that is 0, we want to keep as it is. Correct. So Q1 on 0 will just keep on moving to reach the, okay. Now when you reach the first, keep that first one as it is, but now your action is different. See, after that your action is different, so you need to change. Yeah, after this 1 is replaced by 0, 0 is replaced by different, so we need to change the state. Okay, so in the Q1, if you get the as it is, but now we'll change state to move to the left. Is that clear? Why we change the state? That is not performed. So that's why we are changing some to some other state. Let now you are in the Q2 state. Okay, so for this example, what it will do? 0 hai, so it will keep moving left. And now whenever it reaches 1, whenever it reads, we change state to the Q2 and move. So after this, now your state is changed to the Q2 and now the input is 0. So what is my action now? In the Q2, this will fill later on. In the Q2, now you are in the state Q2. Q2 में क्या करना है हमें? In the Q2, if you get 0, what is the action? In the Q2, what is the action? See, now after this one, यहाँ तक as it is हमने रखा है. The first one, after that, what you have, yes, that is correct. That is, you will one remain in the same state, and remaining to the same state, no need to write 1 Q2 L, no, you can just write 1 L. Is that clear? 0 is replaced by 1, so this, and now we'll move to the left. In the Q2 state, if you get 1, what is to be done now? What is our output? C, 1100 already we produced here. In the Q2, if you get 1, what is to be done? What we want here? 1, we want that 1. 0 is replaced by 1. So 1 is replaced by 0, no? And you remain in the same state. So 0L, replace 1 by 0 and move like this way in the Q2 state. Okay, and now what happened? Let me check. Is it clearly? Is my page clearly visible? Maybe net issue. Let me check. Yeah. Let me check. Just a minute. Yeah. Is it visible now? No. Okay. Let me check what happened to the net. Okay. Is it visible now? Am I audible? Is the page visible? Hello, anyone, please inform. So we continue the example. Atharva, is it visible? No, I don't know. Some net problem is there. Hmm. Okay, just wait. Just a minute. Light problem. Rohan, just check whether it is clear or it is fully blurred. Is clear?